welcome back. We are now on to 7.2, which is the second half of the lecture for Monday. This was originally going to be the lecture for Monday the 16th, that is March 16th, but it's now officially the lecture for March 23rd. But I wanted to get both 7.1 and 7.2 up on YouTube for you as soon as possible because I want you to be able to work ahead, or at least to have the flexibility to work ahead if you would like to do so. So the homework from 7.1 and 7.2 is going to be due on Wednesday, March 25th, rather than Wednesday, March 18th, as it originally said in the syllabus. So now you will have it a week early, or at least 5 days early. Rather, the lecture is now up 5 days early so that you can get started on it if you would wish to. So that gives you a full week to complete the homework for these lessons. So 7.1 I already posted, and this is 7.2, which is the second half of the lecture. So 7.2 is about rational exponents. In a previous version of the text, it was later on in chapter 7, and one thing I'm really happy about is that this version of the text actually moved 7.2 closer to the beginning of the chapter, and that's helpful because rational exponents are something that I use with the calculator a lot. Okay, so for instance, on the calculator, you can use the square root button, okay, to do the square root of 9 on the calculator. And of course, if you use the square root button on the calculator, the output is 3. But this exact same expression can be typed into the calculator using what are called rational exponents. The rational exponent notation has you take the 9 and use the caret symbol on the calculator. You use the caret symbol and you raise the 9 to the 1/2 power on the calculator, and this results in the same output. So what I've written here in the way that I would type it into the calculator is actually what in the book would be written as 9 to the 1/2 power. Okay? So what I'm saying is that this notation is called radical notation. Radical notation. This notation right here is the notation for rational exponents. Okay? So, the radical notation uses the radical sign, the square root sign, the cube root sign, the fourth root sign, the signs that we saw in 7.1. Whereas the rational exponents uses an exponent to express the square root or the cube root or the fourth root. And the way it expresses it is through a fraction. And that fraction is a rational number. That's why it's called a rational exponent. So the denominator of the number tells you what sort of root you have. The denominator here is 2. The 2 means square root. If the denominator is 3, it means cube root. Okay? So let me take you over to the other side of the board here. On your homework on MyOpenMath, there is a multiple choice question, question 15. And it has you identify the radical notation that corresponds to 7x to the 1/2 power. So what I want you to notice here is that the 7 is not attached to the x using parentheses, okay? So the 7 just stays a plain old 7. But x to the 1/2 power is the square root of x, the square root of x. The reason is that this 2 right here in the denominator of the rational exponent means square root. So you may be wondering, what about the numerator? The numerator 1 tells me that what's in the square root is raised to the first power. So this is actually x to the first power. So that's the 1. The 1 right here is the 1 right here. And the 2 in the denominator is the 2 that's implied right here in square root. Okay, you do not need to write this 1. That's not required. Okay, so now let's look at question number 16. And this is just the version that was generated for me. Your questions will be different numbers, but it's the same type of question. Right here, the 4 in the denominator tells me that I have a 4th root. 4th root, okay? The 3 in the numerator tells me that what is inside my 4th root is x to the 3rd power. And that's how you transfer from the rational exponent form to the radical form, okay? Rational exponents, radical form. These are exactly the same thing written using 2 different notations. So now I skip down to question 18 here. And in question 18, I have radical notation. And that radical notation now needs to be written as a rational exponent. Okay, so let me put the computer down, bring it over here, so you don't have to see a sideways version of this problem. Okay, is this better? So what I have here is a 6th root. Now, the 5 and the 2 in the exponents here, remember these become the numerator. So we have a to the 5th power divided by 6. Okay, so 5 is the numerator. The denominator matches this number right here. The 6th root becomes the 6 for the denominator. Now for b, the 2 is the numerator. The 6 is the denominator. And this is now the rational exponent form. Now, if it doesn't ask you to reduce it, you don't have to reduce it. Of course, this can be rewritten as b to the 1/3 power, but you don't have to do that if the question is simply asking you to rewrite it using rational exponents. Then, in terms of rewriting it using rational exponents, this is rewriting it using rational exponents. If it asks you to simplify, then you continue to simplify. So it just depends on the nature of the question, what the directions are. Okay, so then the next question is, once you understand how to go back and forth between radical notation and rational exponent form, how can you simplify an expression without using a calculator? And so question 19 right here, 625 to the 3/4. I'm going to show you how to switch this into radical form. After we're in radical notation form, then we simplify. And then if we need to go back to rational exponent form at the end, we will. And we'll do that for question 19 and question 21. Okay, so question 19. So first of all, this 4 right here is the 4th root. And then the 3 is the exponent that 625 is raised to. How do you do 625 to the 3rd power without a calculator? I cannot do that. My guess is you cannot do that either. If you can, that's very impressive. Well, as it turns out, this is only one of 2 ways of writing this. This right here, what you see on the board, is actually equal to, wait for it, the 4th root of 625 raised to the 3rd power. In other words, what I have written here, 625 to the 3/4 power, can be written either way. They're both the same thing. All three of these mean the exact same thing. These are both written in radical form, and this is the rational exponent form. But both of these mean the same thing. So which way do we write it? Whichever way is easier for us. Not easier to write it, but easier to simplify. Okay, so I can do the 4th root of 625. Now, if you can't figure out the 4th root of 625, that's fine. You can use a calculator for that. But we're trying to understand the notation rather than just type it in the calculator. If you type 625 to the 3/4 into the calculator, it will give you the answer. But that's not going to help you understand the concept. And you really need to understand the concept as we go forward and it gets harder. Okay? So if you need to do the 625, the 4th root of 625 in the calculator, that's fine. So think, though, what two numbers multiply to 625? 25 times 25 is 625. If you didn't know that, that's okay. But because 25 is also 5 times 5, I know that 5 times 5 times 5 times 5, 4 copies of 5 times 5 times, that is going to be 625. So this is also 5 to the 3rd power. Okay, I simplified the 4th root of 625 to 5, and then this 3rd power is still here. This is still the 3rd power. So this is 5 to the 3rd power, and 5 times 5 times 5 is 125. So that is how that one is done without a calculator. The key is, yes, you can use a calculator for some of those things if you need help, but go through the process. What you need to do is first transform rational exponents into radical form, then simplify using radical form. Okay? Let me show you again for question 21. First, rewrite this. So notice, the 3 in the denominator has now become this 3, indicating that I have a cube root. And the 5 in the numerator tells me that I'm taking the 5th power. So, let me get this a little closer. Sorry, don't want you to get motion sick. The cube root of 64 is 4. 4 times 4 times 4 is 64. Now this is 4 to the 5th power. Oh goodness, what is 4 to the 5th power? 16 times 16 is 256. 256 times 4 is... I think that is the answer. Let me pause for a moment and check. Okay, so I tried to check that, but I still couldn't bring up my calculator, so I did it by hand on the board, and I'm 99% sure that's right. All right, so now let's look at question number 22. What do we do when we have a negative exponent? Well, remember that the negative exponent is like the elevator button that sends the guy downstairs. Okay, so first rewrite it like this. Simply take the negative exponent and cause the x to the 5/9 go downstairs to the denominator. Now, once you have it down there, then you can use the radical notation. Let me put this down. Okay, ta-da! So once you understand how that works, you can come up and do a problem like this. All right, so what we want to do first is we're going to move it downstairs, just like we did back here, where we pulled it downstairs first, and then we turned it into radical notation. So over here, I'm going to do the same thing. Okay, so let me summarize. First, I'm pulling down this 64 to the 4/3 down to the denominator. Then I'm rewriting it using the radical notation. Since the cube root of 64 is 4, I then have 4 to the 4th power. See, 4 to the 4th power, which is again one of those problems that I hope I'm doing right in my head, but 4 times 4 is 16, 16 times 16 should be 256. Yeah, because that's 160 plus, whatever. Anyway, 160 plus 96? Yeah. Okay, so those are some of the easier problems, and then what I have here is what looks like a kind of a messy problem. It's really not that bad. It really just goes back to 5.1. If you need to review 5.1, go and do so. 5.1 was when we had all of those exponent rules, right? Okay, so what I have here is the power rule. And this is kind of easy because as this was generated in this particular problem, I have a 1 here. And a 1 is not very exciting to work with, but this is the problem that was generated, so I'm going to do this version of the problem. So what I have is the 5/7 power up here on the outside. This is going to apply to both exponents. Remember that the power rule says that if you have a power raised to a power, then you multiply. 1 times 5/7 is just 5/7. Seven 6 times 5/7, the 7ths will cancel. 7 and 7 cancels, leaving you with 5/6. If that's a little tricky to see, write it like this. Now, just a reminder, I had said this in class, but some students still didn't follow the directions on the test that I had given in class multiple times. Do not cross out your work. If you cross out your work, I will either not be able to read it, or even if I can read it, it might be a little ambiguous. And so if you cross out your work, it will be like that work is not there. In general, if you cross work out, I am looking at that work as though it's not there. Do not cross out your work. If you must, use a highlighter and then I can still read it, or use the check marks. But anyway, you can see here, the 7 and the 7 cancel, and that leaves you with 5/6. That's why I have a 5/6 right here. Now, the denominator I will copy as is. So, that was the power rule. Now, I am going to use the quotient rule. Now, remember with the quotient rule, if you have a power divided by a power, you subtract the exponents. Okay, let me give you a simple reminder. A to the 8th divided by A to the 3rd power, 8 minus 3 is 5. Okay, remember that? That was the quotient rule. So we're going to do the same thing here, except now we have fractions. So you need to know how to be able to subtract fractions like an elementary school student. Okay, so first off, we have the 5/7 minus 3/7. 5/7 minus 3/7 is 2/7. Okay, and then we have 5/6 minus 4/21. That's a little trickier. When you have two fractions, remember you need to have a common denominator. So I'm going to multiply this by 7/7, and this by 2 over 2, and now the common denominator is going to be 42. And as it turns out, 35 minus 8 is 27, and 27 and 42 are both divisible by 3. So this is 9/14. So you don't have to show this work. This work of 5/6 minus 4/21, 4 over 21. Anyway, all that work you can just do on scratch paper off to the side, or even use a calculator if your calculator knows how to follow that logic. Well, the calculator knows how to follow the logic. The question is whether you type it in correctly. Okay, so this is now going to be 9/14. So your final answer then for this problem, which was a little yucky because of the fractions, x to the 2/7, y to the 9/14. And that corresponds to question number 26 from the homework. Okay, I am going to show 2 more examples and then we will be done with this lecture. So first I want to go over number 82 on page 604. So let me get that one up there. Okay, number 82. B to the 3/5. B to the 2/5. All raised to the 8th power. I'm going to do this problem 2 different ways. It turns out that this one is kind of easy because 3/5 plus 2/5 is 5/5, right? And so 5/5 is the same thing as 1. When you do a problem like this, you still need to show this intermediate step. Why? Because going from here to here uses the product rule. Going from here to here uses the power rule. So if you are using multiple rules, have multiple steps. You can use the product rule and the quotient rule together at the same time, although it's not ideal. Don't use the power rule at the same time as the product or quotient rule. And it's the same thing with PEMDAS, right? The exponent step, E, in PEMDAS, is a separate step than the MD step, the multiplication division step. So just keep those separated. Now, if this problem had not given you such easy numbers to work with, another way you could have done it is you can apply the power rule first. So if you apply the power rule first, it looks like this. So what did I do here? When you have the power rule, you multiply the exponents. 8 times 3/5, 24/5. 8 times 2/5 is 16/5. That was the power rule. And now I can use the product rule to add those together. 24/5 plus 16/5 is 40/5. And that simplifies to b to the 8th power. Okay, the last problem I want to go over is number 104. And the directions should be followed on each of these problems. So when you are doing your handwritten homework that has to have work or intermediate steps, or just make sure that you follow the directions in the textbook, okay? So the problem I'm looking at is number 104 on page 605, and the directions are: use rational exponents to simplify each radical, All variables represent positive real numbers. Remember that that's the disclaimer that allows us not to have to pay attention to when we would use the absolute value symbol. So that's a good little disclaimer there. So the main part of the directions though are use rational exponents to simplify each radical. So the radical I'm going to put up here does not have rational exponents. It's written in a radical expression as a radical expression. What we need to do is transform the radical notation into rational exponent notation, then simplify, then go back to radical notation, okay? So I'm going to erase the board and then do number 104. So I need to copy the problem, which is underneath my laptop conveniently. Cube root and fourth root 21x. So here we have a radical nested inside of another radical. So trying to turn this so that the glare is not interfering with the visual. Okay, so what we want to do is transform into rational exponent notation first. The third root becomes the 1/3 power. That's the outer part. The inner part has a fourth root, so that needs a 1/4 power. And the 1/4 power also needs parentheses, because both the 21 and the x are both inside the radical. We need to have these parentheses. Okay, now that we've transformed our radical into rational exponent notation, we can use the power rule. 1/4 times 1/3 is 1/12. And the parentheses are still required. This is the final simplification, but we need to go back to radical form because the original problem was written in radical form, so we want to maintain the notation of the original problem. So here we go. And that's that. I urge you to look through the examples in the textbook. They are well written and things are explained pretty well in the textbook. And then also there are videos on MyOpenMath. Use as many resources as you need to, even use Khan Academy if that's helpful for you. And also post questions if you need to. I haven't decided exactly what I'm going to do with the forums on Blackboard, but I will make that decision this week, that is before the end of the 20th, March 20th. So if you're looking at this video and it's already the March 23rd or later, then that decision will have already been made and that will be in the revised syllabus. So just check out the revised syllabus as to what you should be doing with the forum on Blackboard. That is under discussion on Blackboard. You'll see some different forums that you can post in, and you can answer other people's questions if you yourself do not have any. All right, talk to you later. Bye.